Hmm. Okay, so the question is, on a foggy day, two drivers spot each other when they are just 80 meters apart. So when they are just 80 meters apart, they are seen each other. Okay, they have seen each other. So 80 meters, they are traveling with a 72 kilometers per hour. They are traveling with 72 kilometers per hour with 80 meters, and in the side on the 60 kilometers per hour. Okay, so both of them apply brakes, retarding their speeds at the rate of 5 meter per second square. So that is, they have given the acceleration as 5 meter per second square on both the sides. But இது வந்து decreasing nala, it is a minus acceleration. We call it as a deceleration, and determine whether they collide or not. So we have to check whether where they are collided with each other or not. One by one. First வந்து இந்த கேஸ் நான் பார்க்குறேன். After that we'll discuss about this one. So first நான் வந்து displacement find out பண்ணணும். To find the displacement, இதுல வந்து initial velocity, final velocity பார்க்கணும். So u is your initial velocity, it is 72 kilometers per hour. After reaching the maximum, that means after reaching the point, it will be your final velocity. So final velocity எப்பவுமே 0 because it was a stop there itself. Okay. So we have to convert 72 kilometers per hour into meter per second. Okay. இது convert பண்ணுங்க. What is the value? Convert it. What is the value? $72 kilometers per hour into meter per second. How to convert? Yes, ma, இது 20. Okay, others, எப்படி convert பண்றது? Anyone? Kilometers per hour to meter per second. Okay. As usual, எதுவுமே பேசாதீங்க. So 1000 meters. Okay, kilometer to meters, 1000 meters, and hours on the 3600 seconds. Okay, kilometer per hour. Okay, into meter per second. So it is 1000 by 3000. So it is 5 by 80. So if you want to convert kilometer per hour to meter per second, just multiply by 5 by 80. 5 by 80. So you'll get approx 20 meter per second. It is 20 meter per second. So now we got the initial velocity and we know the final velocity, acceleration theorem. We are going to find the displacement. So to find the displacement, relations part. So first relation lo displacement கிடையாது. Second relation lo only displacement and initial velocity இருக்கு, time period இருக்கு. So we are going to see the third equation. Third equation என்னது? V square minus U square is equal to 2AS. We are going to find the displacament S. So to find the displacement is, எனக்கு வந்து acceleration தெரியும், which is minus 5. V is equal to 0 and U is minus 20 meter per second whole square is equal to 2 into minus 5 into S1. I'll take it as S1 because of the first case. So from this relation, try to find displacement S1. S1 find out பண்ணுங்க. $40 meters. Yes, ma. So S1 is 40 meters. Good. S1 is 40 meters. Same case we are going to do for S2. Same case we are going to do for S2 also. So here the initial velocity is 60 kilometers per hour. Initial velocity is 60 kilometers per hour. 60. Okay, I'm going to convert into meter per second. What is the value? 60 kilometers per hour to meter per second. So just multiply by 5 by 80.
8.6.
8.6. Okay, 8.6. Final velocity V is equal to 0. Okay, and acceleration is minus 5. So from this relation, V square minus U square is equal to 2AS. So we are going to find S2. So what is the value of S2? Try to find. What is the value of S2? What happened? ரொம்ப நேரம் பண்றீங்க, கொஞ்சம் சீக்கிரம் பண்ணுங்க. S2 find out பண்ணுங்க இதுல. Yes, ma. Yes. So S2 is equal to approx 27.7 meters you will get. S2 or 27.1 is fine. So here the total displacement S1 on the we got around 40 meters. S2 yes,
in meter per second 16.6, sir.
Which one? Velocity.
U.
This is 16.6. 16.6. 1 second. Yeah, and the answer is another. Okay, so 60 into 5 divided by 18. Right now. Sorry. So the answer is 16.6 meter per second. Yes, correct. Okay, so it is 16.6 meter per second. So S2 will get around 27.7 meters. So 27.7 meters. So இப்போ இது முன்னாடி நம்ம question பார்க்கும்போது the total displacement between the two vehicles is 80 meters ன்னு சொல்லியிருக்கோம். Suppose he hit the brake, so brake hit பண்ணதுக்கு அப்புறம் he was traveling around 40 meters. And in the vehicle he was traveling around 27.7 meters. Okay, so what is the total displacement? S1 plus S2. So S1 plus S2 is 1.7 meters. So it is less than the 80 meters. Correct? So 80 meters will be lesser than. So if it is lesser than the 80 meters, so there is a space between these two. So these vehicles will not collide with each other. These two vehicles will not collide with each other. That is your answer. Okay. Right. Next question, Papa. Next question. In the question, you can try பண்ணுங்க. I'll read the question. A 100-meter sprinter increases her speed. 100-meter sprinter increases her speed from rest uniformly at the rate of 1 meter per second square. Uniformly at the rate of 1 meter per second square. 1 meter per second square. I'll repeat the question again. A 100-meter sprinter increases her speed from rest uniformly at the rate of 1 meter per second square up to 3 quarters. 1 meter per second square up to 3 quarters of the total run. 3 quarters of the total run, and covers the last quarter with uniform speed. How much time does she take to cover the first half? How much time does she take to cover the first half and the second half of the run? How much time does she take to cover the first half and the second half of the run? I'll repeat the question. A 100-meter sprinter increases her speed from rest uniformly at the rate of 1 meter per second square up to 3 quarters of the total run, and covers the last quarter with uniform speed. How much time does she take to cover the first half and the second half of the run? Okay, now, so here there is a sprinter. That sprinter, she was running the total distance of 100 meters. The total distance of 100 meters. Idhula on the 4 quarters irukku. So they have given first 3 quarters with the acceleration of 1 meter per second square. So first 3 quarters she was running with an acceleration of 1 meter per second square. So that means if the A point and solren, idhula on the B point and so the total distance is 100 meters. Idhula on the 3 quarters and solumbodhu. So first 3 quarters and solumbodhu it is 50, 75 and 100 I. Okay, first 3 quarters she was getting the acceleration A is equal to 1 meter per second square. Okay, A is equal to 1 meter per second square. So you get 25. Okay, 25, 50, 75. These are the 3 quarters. And the last quarter with a uniform velocity. This is your question. Okay, now we need to find the time period for the first half as well as the second half. So, and one more thing. So, first half and till 50 meters is your first half, T1, அதே மாதிரி after that till 50 the balance 50 meters as your time period t2. Okay, so these are your relations. இதுல வந்து acceleration and we know about the displacement. இது மட்டும் தான் நமக்கு தெரியும். One by one we'll see. So in the relation, first I'll try to find the first of time period. I'll try to find the first of time period. So to find the time period, first initial velocity என்ன இருக்கு, acceleration, final velocity, எல்லா details I'll try to find. So for the case of A point, and I'll take this 50 meters as C point. Okay, quarter as a T point. So A to C, I'll try to find the time period for A to C. So first displacement S1, I'll take it as S1, okay, which is 50 meters. Okay, so first half, it is 50 meters, right? So acceleration already kuduthirukka, which is 1 meter per second square. And anyway, she was running from the initial condition u equal to 0, making initial velocity u equal to 0, right? So these are your relations. Enakku vandu time period when. Okay, so final velocity I don't know because it is first half 50 meters. Now, so from this relation, which is second equation, s is equal to ut plus half a t square. From this relation, try to find t1. Okay, from this relation, try to find t1. t1 find out பண்ண சொல்லுங்க. So s தெரியும், acceleration தெரியும், initial velocity தெரியும், t1 find out பண்ணு.
10 seconds, sir.
Yes, one. So t1 is 10 seconds. Good. t1 is 10 seconds. Now we got the t1. So now for this case, for the second quarter, next quarter, so 50 kaprama on, there are two quarters are there. So 25 meters and 25 meters. These are your quarters. So for the third quarter, we know the acceleration. For the third quarter, we know the acceleration, but fourth quarter, we don't know the acceleration. So for that, so we are going to find the time period for the next case. Next case in the sense from A point to D point. A point to D point. So A point to D point, now on the total time period, I find it pantena, idhula na on the less panilla. Now, so for the next case, I erase panidren. Next case, so now I'm going to find the time period between A point to D point. A point to D point is nothing but between the three quarters. So either C and either D, and the total displacement is 75 meters, and it is a B point. So we are going to find the time period for A to D. So to find time period for A to D, again, so initial velocity u equal to 0, acceleration on the 1 meter per second square, and the displacement s is equal to 75 meters. Okay, so from the same equation, try to find the time period t. T find out பண்ணுங்க.
$12.2 seconds, sir.
Yes, ma'am. T is equal to 12.2 seconds. So assume it is your T1 and it is your T2. Now, remember, இதுக்கு முன்னாடி நம்ம வந்து AC க்கு find out பண்ணிருக்கோம் time period. Now, இப்போ AD க்கு find out பண்ணிருக்கோம். So AC க்கு find out பண்ணா, the relation is around T1 is 10 seconds. Okay, AD க்கு find out பண்ணா, the time period is 12.2 seconds. So I need to find CD. So it is nothing but 12.2 minus 10 seconds. So the time period is around 2.2 seconds. CD time period is 2.2 seconds. Right. So this is the case. Now, what we'll do, we are going to find the velocity because the fourth quarter we don't know the acceleration. We only know the uniform velocity. We only know the uniform velocity. Uniform velocity na earlier in a quarter velocity irukku adhe velocity da travel aayirukku but different acceleration. So fourth quarter we don't know the uniform velocity and we don't know the acceleration. So first we'll try to find the velocity with which it was moving. Now, so for this case, total time period eda irukku, it is 12.2 for the three quarters. We are going to find the velocity for the three quarters. Now, so for this AD case, we are going to find the velocity. Now, we know the initial velocity u equal to 0. Okay, u equal to 0. And acceleration theorem, which is 1 meter per second square for the three quarters. And time period, we know that t is equal to 12.2 seconds. T is equal to 12.2 seconds. These are your relations. Now, in the relations based bunny, we are going to find the final velocity. V is equal to u plus at. V is equal to u plus at. So try to find the velocity with which
12.2 meter per second,
Yes,
sir.
ma'am. So 12.2 meter per second. Now we got the velocity. We got the velocity. Now for the next case, for the fourth quarter of the D to B. For the fourth quarter D to B, the displacement is S is 25 meters. The displacement S is 25 meters. So input displacement and theorem, velocity theorem, we are going to find the time period. So velocity is equal to displacement by time period. So time period is equal to displacement by velocity. So try to find it.
Point 0.02, sir.
Now what is the answer?
2.02.
2.02. Yes, ma'am. 2.02 or 2.04. So second half on the 2.2 plus 2.04 is your answer. So answer is around 4.24 seconds is the second half. 4.24 seconds is the second half. आता है को बोलो मैं. Okay. So just take the question. I'll be back. Okay, just see the question. I'll be back in 1 minute. 1 minute, I'll be back. Okay, ma, take the next question. இது நீங்க try பண்ணுங்க. Take the next question. A motor car starts from rest. Motor car starts from rest and accelerates. Motor car starts from rest and accelerates uniformly for 10 seconds. Accelerates uniformly for 10 seconds. Uniformly for 10 seconds to a velocity of 20 meter per second. To a velocity of 20 meter per second. Okay, it then runs at a constant speed. It then runs at a constant speed and is finally brought to rest. It then running with a constant speed and is finally brought to rest in 40 meters. Finally brought to rest in 40 meters with a constant acceleration. Constant speed is constant acceleration. Okay, so the total distance covered is 640 meters. Total distance covered is 640 meters. Find the acceleration, okay, retardation and total time period. Acceleration, retardation and total time period. Try to find it. Acceleration is 12.8. Acceleration is not 12.8. Acceleration is minus 5 meter per second square. Okay, I'll repeat the question again. The question repeat check. A motor car starts from rest and accelerates uniformly for 10 seconds. Starts from rest and accelerates uniformly for 10 seconds to a velocity of 20 meter per second. To a velocity of 20 meter per second. So they already given the acceleration, 20 meter per second is your velocity. It then runs at a constant speed and finally brought to rest. So it was brought to rest for in 40 meters with a constant acceleration. Total distance covered is 640 meters. Find the value of acceleration, retardation, and total time period. So we'll see one by one. See one by one. So here the car starts from rest condition and accelerates uniformly for 10 seconds. Accelerates uniformly for 10 seconds. Okay, to a velocity 20 meter per second. To a velocity 20 meter per second. It then runs at a constant speed and is finally brought at rest. Okay, in 40 meters. So he was running and finally it was brought at rest. Okay, for within the distance of 40 meters. Within the distance of 40 meters. Okay, so with a constant acceleration. Here it will be constant acceleration. Constant acceleration. So the total distance covered is 640 meters. The total distance covered is 640 meters. Okay, find the value of acceleration, retardation, and total time taken. We need to find the acceleration, retardation, total time period. Now we'll see one by one. For the first one, you see that 10 seconds on the first part on I. So either a displacement on the I'll take as S1, I'll take as S2, I'll take as S3. There are three different cases. First, we are going to find the acceleration with which it was moving. First case, so here the acceleration we don't know. Velocity another 20 meter per second. Velocity is your 20 meter per second. This velocity vandu v because initial velocity u equal to 0 because it is at rest condition. U equal to 0. Okay. Now time period theorem. T is equal to 10 seconds. T is equal to 10 seconds. From the relation, we are going to find the acceleration first. From the relation, v is equal to u plus at. Find the acceleration from this. Find the acceleration from it. V is equal to u plus at. And from this relation itself, we are going to find the displacement S1. S1 I find out from. So S1 is equal to that is ut plus half a t square. Try to find the S1 from this relation. Slow பண்ணுங்க ஃபாஸ்டா வேணா இப்போதைக்கு நம்ம ஸ்டார்டிங் டேஸ் ஒரு 1 week 1.5 week நான் ஸ்லோவா போறேன் ஸ்டெப் பை ஸ்டெப் ப்ராப்ளம்ஸ் பிராக்டிஸ் பண்ணுங்க ஆஃப்டர் தட் we'll see. What is the acceleration value?
A is equal to 2 seconds.
Yes, ma'am. 2 meter per second square.
Yes.
2 meter per second square. Then what is displacement? Displacement is 100. Yes, ma'am, Sweta. Yes. Displacement is 100. Yes, is 100. Good. So we got the displacement, we got the time period and the acceleration. Now, for the third case number already theorem, which is 40 meters. Third case, the displacement is 40 meters. Now, so from this relation, then I call the total displacement theorem, which is 640. Appo S2 na find out panalama. S2 find out panala. Eppdina S1 plus S2 plus S3 is equal to 640. Then S2 is equal to 640 minus S1. S1 is 100 and S3 is 40. S3 is 40. So S2 is 500 meters. S2 displacement of the 500 meters. Now we got the displacement S2. Okay. So now you'll see the time period. Time period find out panna S2. Or idhula edha doubt irukka? Ipo first part mattum da namu pannirukom. So again we have to find the retardation and the time periods. So till that edha doubt irukka?
No, sir.
Okay. So note பண்ணிட்டீங்கன்னா I'll erase it. Now, so we are going to find the time period for displacement S2. Time period for displacement S2. And remember one more thing. This object S2 was traveling with a constant speed. Constant speed na inga enna speed irukko, enna velocity irukko, adhe velocity it will try to travel. Now we are going to find the time period. Time period another, it is displacement by velocity. So it is time period for T2. Okay, so in the portion time duration. Okay, so time taken for displacement S2. So T2 is equal to S by V. S on the it is 500, V on the it is 20. So what is the time period?
25 seconds.
Yes, ma'am. Correct. So time period is 25 seconds for second position. Now, third position, S3. So we are going to find the third position S3. So S3 we know which is 40 meters. S3 we know which is 40 meters. And remember, inge vandu idoda initial velocity as usual it is 40 meter per second. Ena final velocity V equal to 0 because it was stopping. So 40 meters vandadukku apparama it was going to stop. So that means inge acceleration vandu retardation irukum. The acceleration vandu retardation irukum. So in this relation we are going to find the retardation. We'll see one by one. So in this case, so initial velocity U equal to 20 meter per second. U is equal to 20 meters per second and final velocity V equal to 0. Final velocity V equal to 0. Right? So we are going to find the acceleration and displacement we know which is a 40 meters. It is 40 meters. From the relation V square minus Q square is equal to 2as, we are going to find the acceleration. Try to find the acceleration from it. Try to find the acceleration. V square minus U square is equal to as. V is equal to 0, U is 20 meter per second, S is equal to 40 meters.
10 meter per second square.
How much, ma?
10.
10 கிடையாதுமா. ஒரு தடவை பார்த்துக்கோங்க. 10 கிடையாது. So V 0 இருக்கு. U வந்து 20 square. Okay. So 2A, S வந்து 40. S வந்து 40. இது 20 square இருக்குமா. Minus 5, yes ma. Yes, so Sweta. So the acceleration is minus 5 meter per second square. We got the acceleration, right? So can we find the time period T3 for this case? Time period find out பண்றீங்களா? எனக்கு acceleration தெரியும், initial velocity தெரியும், final velocity தெரியும், displacement தெரியும். Try to find the time period from it. Relation நீங்களே choose பண்ணுங்க. Relation choose பண்ணிட்டு try to find the time period.
Four seconds, sir.
Time period is around 4 seconds. Good. Time period is 4 seconds. Okay. So then on the S3 position 4 seconds, T2 position 25 seconds. So what is the total time period? It is 10 plus 25 plus 4 seconds is your total time taken. So the total time period is 39 seconds. Total time period is 39 seconds. Okay. Segment wise the questions here. You have the question understand point, try to find it. Okay. Right. So இது பேஸ் பண்ணி questions நிறைய இருக்கு, நீங்க practice பண்ணுங்க. So next case நம்ம பார்க்கலாம். So next one was motion under gravity. Motion under gravity. So இப்போதான் நீங்க வந்து gravitation பேஸ் பண்ணி நீங்க டிஸ்கஸ் பண்றீங்க problems. Next slide again இது வந்து vertical conditions பேஸ் பண்ணி தான் இருக்கு questions. Okay. So இந்த questionல ஏதாவது doubt இருக்கா? Yeah, any doubt please ask me that or else I'll erase these things. Any doubts? No sir. Okay, fine. So next one, make a heading, motion under gravity. Make a heading, motion under gravity. So when we are discussing about the motion under gravity, அதே 3 equations வரும், but in the 3 equations it was with respect to acceleration due to gravity. இதுல ரெண்டு cases இருக்கு. First case was with respect to acceleration due to gravity, which is away from the ground. It is moving upward direction. Second case, the acceleration due to gravity, the object was towards the ground, towards the surface. Now, we'll take the relations. When the acceleration due to gravity is away from the earth, what will happen? It is away, then it is minus. When it is towards, it is plus. Same relations, instead of acceleration, we are going to use the acceleration due to gravity. Formulas part. So first relation, V is equal to U plus GT, because it is away from the acceleration due to gravity, which is away from the earth. If it is away, then it is minus GT. Okay, second case, S is equal to UT minus half GT square. Third case, V square minus U square is equal to minus 2GS. Okay, so instead of acceleration, now the acceleration due to gravity is there difference. Only depends upon the direction away from the earth or towards it. We are going to discuss this. Next, here it is towards the earth, it is plus. So first relation is V is equal to U plus GT. Second relation is S is equal to UT plus half GT square. Third relation is V square minus U square is equal to 2GS. U square is equal to 2GS. Okay, so from this relation, we are going to do some sums. Then we'll see the graphs. Okay, have you taken this one? You already know this relation, right? Okay, take a question. Or question note panikonga. S is equal to H. Yes, ma. S is equal to H. Good. So here, S ke H ke there will be small difference. Okay, na solren. Okay, so just take the question. A ball thrown vertically upwards, a ball thrown vertically upwards with a speed of, a ball thrown vertically upwards with a speed of, vertically upwards with a speed of 19.6 meter per second, with a speed of 19.6 meter per second. Okay, from the top of a tower, from the top of a tower, returns to the earth in 6 seconds. Returns to the earth in 6 seconds. Find the height of the tower. Find the height of the tower. I'll repeat the question. A ball thrown vertically upwards with a speed of 19.6 meter per second from the top of a tower returns to the earth in 6 seconds. Returns to the earth in 6 seconds. Okay, so find the height of the tower. Find the height of the tower. Now we'll see one by one. So we know the initial velocity, correct? So we know the time period. It was taken t is equal to 6 seconds. And now remember, when it is thrown upward direction from the height of a tower. So the height of a tower is from the ground. So I have thrown this object upward direction. After 6 seconds, it was reaching the ground. Okay, we are going to find the height of the tower. Height of the tower. Okay, so when we are discussing of the displacement and so on, when the object was traveling from one point and it is returned back to the same point, the total displacement or the net displacement is equal to 0. Okay, so object on the point and the start at point repeat we call it as total displacement. The total displacement is equal to 0. Total displacement or net displacement is equal to 0. So from this case, so in displacement height relations. Now, so in the conditions, so here assume the object was moving from this point. Assume the object was moving from this point and it is returned back to the same point. The displacement is equal to 0. So that means the total path which it was covering, I'll take this S. The total path which it was covering, I'll take this S, and H, it is the height of the building. So we know that the total displacement is equal to 0. So that means S plus H is equal to 0. S plus H is equal to 0. When S plus H is equal to 0, what is the displacement? Which is minus H. The displacement is minus H. So we are going to find the height H with this relation. Now, so we know the initial velocity, time period, and the displacement. From the relation, S is equal to UT plus half GT square. But acceleration due to gravity is in opposite direction, so it is minus. It is minus. So acceleration due to gravity, just take G as 9.8 meter per second square. G as 9.8 meter per second square. So S is nothing but your minus H. The displacement is nothing but your minus H. Now try to find the height from this relation. Height find out pananga.
Minus 58.8 meter.
It is 58.8 esma. Yara the Mahava.
Yes, sir.
8.8 meters. So the height is 58.8 meters. Okay, others just the relation மட்டும்தான் memorize பண்ணிக்கோங்க. So வேற எதுவும் புதுசா எதுவுமே இல்லை. So இங்க வந்து total displacement 0 ஆயிடும். So s plus h is a total displacement. S is equal to h ன்னு நினைச்சிட்டேன், which is minus h. Because s plus h, the total displacement is equal to 0. Now initial velocity தெரியும், time period தெரியும், and acceleration was moving upward direction. So it is minus c. Okay, over. We'll see next question. Note பண்ணிட்டீங்களா? Answer note பண்ணிக்கோங்க, so you can try it later. Done? So answer is 58.8 meters. Note பண்ணிட்டீங்களா? Yes sir, okay fine. Others response இல்ல. ஸ்வேதா, மகா, ஃபசல், நீங்க 3 பேர் தான் பேசுறீங்க. தினேஷ், என்னாச்சு? Yes sir, sweetie Epsiva. Okay, next question. Okay, next question. Next question. Two balls are thrown simultaneously. Two balls are thrown simultaneously. Capital A ball, vertically upwards. Capital A ball, vertically upwards, with a velocity of 20 meter per second. With a velocity of 20 meter per second. 20 meter per second. Okay. From the ground, and B vertically downwards. And B vertically downwards from a height of 40 meters. From a height of 40 meters. The total height from the ground is 40 meters. It was moving vertically downward directions. Okay. So with the same speed, both speeds are same speed. Okay. And along the same line of motion. So these two are traveling the same line of motion. At what points do the two balls collide? At what points do the two balls collide? We are going to find the distance where it was colliding with each other. Okay, so we know that initial velocity is, it is 20 meter per second. Here is also it is 20 meter per second. So the final velocity v is equal to 0 because these two are colliding with each other. We are going to find the displacement. Now to find the displacement, இப்போ நான் என்ன நினைக்கிறேன்னா, so here from A point, assume this point is as a C. From A point to C point, I'll take it as X. From A point to C point, I'll take it as X. So for B point to C point, it is 40 minus X. It is 40 minus X. Okay, so it is X and it is 40 minus X. Now we'll see the relations one by one. So in this relation, first case na pakra, which is A to C. A to C na pakra for the A ball. When we're discussing about the A to C, the relation, so here initial velocity u is 20 meter per second and acceleration due to gravity, it was moving upward direction. So g is minus 9.8 meter per second square. G is minus 9.8 meter per second square. So எனக்கு வந்து initial velocity இருக்கு, g இருக்கு. So we will find the displacement. See here the displacement is nothing but s as x. Displacement is nothing but x. Okay, time period எனக்கு தெரியாது. So there will be a relation. We are going to create a relation here. X is equal to ut minus half gt square. So எனக்கு வந்து u value தெரியும், g value தெரியும். So when you are substituting the relation, we will get x is equal to 20t. X is equal to 20t minus 4.9 t square. It is your first equation. 4.9 t square. It is your first equation. Okay, just take this relation. In the case for A to C, this is for A to C. Same thing, we are going to find the relation for B to C. B to C. Then when you are solving those two equations, you'll get the displacement x. That is your answer. Okay, so note பண்ணிட்டீங்களா? Is there either doubt in the, please ask me. The doubt இருக்கா?
No, sir.
Okay, fine now. So for the second case, B to C, the displacement is 40 minus x. the displacement is 40 minus x, and it is going towards the earth. So it is moving downward direction. When it is moving downward direction, so it will be plus. So it is 20t plus 20t plus 4.9 t square. 20t plus 4.9 t square. It is a second equation. So we got x is equal to 20t minus 4.9 t square. Second equation, 40 minus x is equal to 20t plus 4.9 t square. So in the render relations, we are going to add. Okay, so we are going to add these two relations. When you are adding the two relations, the final relation will be x is equal to okay, or when you are adding, xx will get cancelled, xx cancelled, and here 40 is equal to 40t, 40 is equal to 40t. You'll get 40 is equal to 40t. So from this relation, t is equal to 1 second. Now we got the time period, t is equal to 1 second. If I'm going to find the displacement, the first relation in the second relation now substitute. So now first relation, so x is equal to 20 into 1 minus 4.9. X is equal to 20 minus 4.9. It is 15.1 meters. X is nothing but your 15.1 meters from the bottom to the C point. So it is your height with which these two are colliding with each other. So you can able to find it. So now base and then find out. Okay, this is your answer. Time period under 1 second and displacement under 15.1 meter. The doubt irka? Okay, fine, ma. Right. So you'll see the next case. Please, either doubts in the please ask me there itself, and the doubts ange clarify பண்ணிக்கோங்க. நான் வந்து next step போயிட்டே இருப்பேன். Problems பண்ணிட்டு we'll see the graphs. There are so many things are there. Okay. நான் ஒரே டாபிக்ல வந்து நம்ம உட்கார்ந்து இருக்க முடியாது. So இதை விட important topics இருக்கு. Once நான் வந்து laws of motion complete ஆனதுக்கு அப்புறமா directly we'll see the gravitation and directly we'll see the electrostatics. Class 12 topics போலாம். நான் ஆல்ரெடி சொல்லிட்டேன் important topics நம்ம first cover பண்ணிட்டு non important topics நம்ம last பார்ப்போம். Okay, so any doubts? So next question, take next question. இதை நீங்களே try பண்ணுங்க. Next question. A rocket is fired vertically. Take the question. A rocket is fired vertically. A rocket is fired vertically from the ground. Fired vertically from the ground with a resultant vertical acceleration. Is 10 meter per second square. With a resultant vertical acceleration is 10 meter per second square. Full stop. The fuel is finished in 1 minute. And it continues to move up. What is the maximum height reached? Okay, so next question, the same question, I'll repeat the question. So a rocket is fired vertically from the ground with a resultant vertical acceleration of 10 meter per second square. The fuel is finished in 1 minute and it continues to move up. What is the maximum height reached? So try to solve it. So they got the acceleration, time period 1 minute கொடுத்திருக்காங்க, and we need to find the maximum height. Try in your own way. So if not, I'll help you with it. Okay, relations மட்டும் நான் சொல்லிடுறேன், நீங்க சால்வ் பண்ணுங்க. இதுல வந்து there are two cases are there to reach the maximum displacement or maximum height. Two cases. First case என்னன்னா with fuel. So height covered with fuel 1 minute. 1 minute, what is the displacement? S1. So time period theorem, acceleration due to gravity theorem, and g you just take it as a 10. So g as 10 meter per second square. G as 10 meter per second square. Okay, now so velocity attained after 1 minute. We are going to find the velocity after 1 minute. So the with which it was moving. So v is equal to u plus at. V is equal to u plus at. So in this relation, we are going to find the velocity. So displacement find out பண்றீங்க, velocity find out பண்றீங்க. Okay, after this, so fuel complete ஆனதுக்கு அப்புறமா, what is the displacement? It was travel. So we are going to find S2. We are going to find S2 from the relation v square minus u square is equal to 2gs. V square minus u square is equal to 2gs. Okay, and when you are adding these two displacement, we are going to find the total displacement and maximum height. Okay, so try it. Okay, so கொஞ்சம் time saving, assume it is your homework question. Okay, எனக்கு நாளைக்கு submit பண்ணுங்க இந்த question. Okay, next question note பண்ணிக்கோங்க. Just submit this tomorrow. நான் answers கொடுத்துடுறேன், நீங்க cross check பண்ணிக்கோங்க, நாளைக்கு வந்து சொல்லுங்க. Okay, answers மட்டும் நான் சொல்றேன். So suppose doubt இருந்தா tomorrow we'll solve it. So displacement S1 is 18 kilometers. Displacement S1 is 18 kilometers, and displacement S2 is 1837.3 meters. Displacement S2 is 18367.3 meters. So the total displacement between these two is 36.4 kilometers. 36.4 kilometers. 36.4 kilometers. And the velocity சொல்லிருக்கு, velocity வந்து after reaching the maximum, so velocity with which it was moving, v is equal to, at this case, v is equal to, it is 600 meter per second. V is equal to 600 meter per second. So these are your values. Note பண்ணுங்க, try பண்ணுங்க. So tomorrow you just tell me about this one. Doubts in the we'll discuss. Next question note பண்ணிக்கோங்க. Next question. Next question. A stone is dropped from a balloon. Next question. The answers note பண்ணிக்கோங்க. We'll discuss this one tomorrow. First நீங்க solve பண்ணுங்க, or else tomorrow we'll discuss this one. Okay. Next question. A stone is dropped from a balloon. A stone is dropped from a balloon, rising upwards. A stone is dropped from a balloon, rising upwards. Upwards with a velocity of 16 meter per second. With a velocity of 16 meter per second. 16. Velocity of 16 meter per second. Okay. The stone reaches the ground in 4 seconds. The stone reaches the ground in 4 seconds. Reaches the ground in 4 seconds. Okay. Calculate the height of the balloon. Calculate the height of the balloon when the stone was dropped. Calculate height of the balloon when the stone was dropped. I'll repeat the question. A stone is dropped from a balloon rising upwards with a velocity of 16 meter per second. The stone reaches the ground in 4 seconds. Calculate the height of the balloon when the stone was dropped. We are going to find the height of the balloon. Okay. Right. Try பண்ணுங்க இது. இது first question மாதிரி தான் இது. Same case. Try to find the height. So u தெரியும், u is 16 and time period is
25.6 meters.
எவ்வளவுமா? 24.
25.6.
No, ma, 25.6 meters. So G has 9.8 meter per second square. 9.8 meter per second square. So we are going to find the displacement. Relation another S is equal to UT plus half GT square, but it is minus G nala. So it is S is equal to UT minus GT square. But remember one more thing. First question நம்ம என்ன discuss பண்ணிருக்கோம்னா ஒரு object வந்து ஒரு starting, so that means the displacement. So when it is starting from one point, return back to the same point, the displacement S is equal to 0. Displacement S is equal to 0. What I'll do, நான் இதை split பண்றேன். ஏன்னா வந்து max height மட்டும் தான் எனக்கு வேணும். Height மட்டும் தான் எனக்கு வேணும். எனக்கு total displacement வேணாம். So இது S, இது height. So the total displacement is S plus H is equal to 0. Then what is S? S is nothing but minus H. So just take the relation S is equal to UT plus half G T square. S is your minus H, G is minus. Try to find the height from this relation. Height on the approximate 14.4 something, you'll get it.
Sir, 14.4.
Yes, ma'am. So the height is 14.4. Others, please do it. கொஞ்சம் ட்ரை பண்ணுங்கம்மா, கொஞ்சம் ரெஸ்பாண்ட் பண்ணுங்க கிளாஸ்ல. I think the answer is 14.4 meters. Sweetie, என்னாச்சு டவுட் இருக்கமா?
இல்ல sir.
Okay, right now. So next heading. So we'll see the graphs now. So next heading, graphs. Adala first one, displacement time graph. First one, displacement time graph. So time graph in the relations வந்து நான் சிம்பிளா நான் சொல்லிட்டு we'll discuss more on graphs. Graphs based பண்ணி questions இருக்கு. And after that, relative velocity ஒரே ஒரு concept இருக்கு. So your motion in straight line will be over. Okay, right. So heading வந்து displacement time graph. So now graph draw பண்றேன், 1 mile I'll explain that. Displacement time graph. So if you see the graph, so x-axis I'll take as time and y-axis I'll take as displacement. Y-axis I'll take as displacement. So first point, first point, if the graph is a straight line, if the graph is a straight line parallel to the time axis, if the graph is a straight line parallel to the time axis, parallel to the time axis. So parallel to the time axis, I'm drawing a graph. It is point A, B. Graph is a straight line parallel to the time axis AB. It means the body is at rest. It means the body is at rest condition. Body is at rest condition. So when the body is at rest condition, what is the velocity? Velocity V equal to 0. For this case, velocity V equal to 0. It is your first point. So கொஞ்சம் நான் step by step நான் வந்து பாயிண்ட் சொல்லிடுறேன், ப்ளீஸ் அதில் நோட் பண்ணிக்கோங்க. ஆர்எஸ் உங்களுக்கு தெரிஞ்சா ஜஸ்ட் கிராஃப் மட்டும் நோட் பண்ணிக்கோங்க. ஓகே, செகண்ட் பாயிண்ட். First point is nothing but parallel to the timeline, parallel to the x-axis. When parallel to the x-axis, velocity irukadu, time period mattum da vary aayittukum. So velocity v is equal to 0. The object is at rest condition. Okay, you can specify here itself. Okay, second point. Second point. If the graph is a straight line, if a graph is a straight line inclined to the time axis, graph is a straight line inclined to the time axis. So the graph is O to C. Graph is a straight line inclined to the time axis between the points O to C. Points O to C. So it shows constant velocity. It shows constant velocity. Constant velocity. It shows constant velocity. Okay, it shows constant velocity. Third case. Third case. If the graph is obtained is a curve. If the graph obtained is a curve whose slope is decreasing with time. The graph is obtained slope curve whose slope is with decreasing time. So it is 0 to D point. 0 to D point. Okay, if a graph is obtained is a curve like OD, okay, whose slope is decreasing with the time. Decreasing with time. So then the velocity is decreasing. Velocity is decreasing. Velocity is decreasing. That is, motion is retarded. Velocity decrease it was slowly decreasing. Retardation is also. Motion is retarded. Motion is retarded. Fourth point. If the graph is obtained is a curve from O to E, from O to E, whose slope is increases with time. Whose slope is increases with time. Increases with time. Then velocity is increasing. Then velocity is increasing. Velocity increase it is your motion accelerated. The motion is accelerated. Okay. The motion is accelerated. Right. Motion is accelerated. Or any doubts on this displacement time graph? Without doubt, Irkama. Okay, next one. Same thing. Instead of displacement, velocity time. Next one, the graphs velocity versus time. Velocity versus time. Velocity versus time. Okay, same graph now. Okay, so instead of displacement, we are going to discuss about the velocity. Velocity. Okay, so take first point, same graph, take first point. First point. If the graph is a straight line, first point, if the graph is a straight line, parallel to the time axis, if a graph is a straight line, parallel to the time axis, which is OB, sorry, which is AB, parallel to the time axis, which is AB, that means the body is moving with a constant velocity. That means the body is moving with constant velocity. The body is moving with a constant velocity. I'll explain again. So first point is when the graph is a straight line parallel to the time axis. When the graph is a straight line parallel to the time axis. When we are discussing about the parallel, it is the displacement. Ipo is the velocity. That means it was moving with a constant velocity. Okay, it was moving with a constant velocity. Because it is parallel to the time axis and velocity is constant move without any changes. So when it is constant velocity, acceleration is equal to 0. Constant velocity, acceleration is equal to 0. It is your first case. Second point. First point of the AB. Second point. If the graph is a straight line, and inclined to the time axis. The graph is a straight line and inclined to the time axis, which is OC. Inclined to the time axis, which is OC. It means the body moving with constant acceleration. Remember, when we are discussing about the velocity time, we will discuss about the acceleration itself. It is constant acceleration. Okay, next one, third point. If the graph is obtained, a curve OD. The graph is obtained a curve OD. Whose decreasing with the time. Whose slope is decreasing with the time. Then acceleration decreases. Acceleration decreases. We can say retardation. Acceleration decreases. We can say it is nothing but your retardation. Okay. Fourth point. If the graph is a curve like OE, like OE, whose slope increases with time. Whose slope increases with time. Increases with time. The acceleration goes on increasing. The acceleration goes on increasing. So acceleration, it was increasing here. So for the line OE. Okay, for the line OE. So this is your graph between velocity and time. Velocity and time. Okay, so next one, acceleration time graph. Next one, acceleration time graph. We'll see acceleration time graph. Done. Any doubts on this one? Velocity, time, displacement time period graphs. So problems வரும்போது எது acceleration, எது retardation, okay, and எது increasing position இருக்கு, எது decreasing position, depends upon the graphs only we are going to do the sums. Okay, next one, acceleration versus time period. Next one, acceleration versus time period. Acceleration versus time period. Okay, ஒரு பாயிண்ட் நோட் பண்ணிக்கோங்க. First point. First point, for uniform motion, first point, for uniform motion, acceleration is 0. For uniform motion, acceleration is 0. Acceleration is 0. 0, comma, displacement time graph. Displacement time graph. Under displacement time graph, it is a displacement versus time graph. Displacement versus time graph. So it is your constantly increasing. Okay, so here uniform motion, acceleration is 0 and displacement time graph is a straight line inclined to the time axis. Inclined to the time axis. That means displacement versus time graph la நம்ம discuss பண்ணும்போது velocity constant னு சொல்லிருக்கேன். When velocity is constant, the acceleration is equal to 0. So for this inclined position, displacement time graph lo acceleration 0 இருக்கும். Okay, it is your first one. Okay, it is your first one. Same thing, idhile second. For this one, the velocity time graph, it is your velocity and time graph. For the velocity time graph, straight line parallel to the time axis. Straight line parallel to the time axis. Parallel to the time axis. So here the velocity is constant again. When velocity is constant, acceleration is equal to 0. When velocity is constant, acceleration is equal to 0. Okay, so this is your second one. So here displacement time, here velocity time. Here acceleration is equal to 0. It was inclined position. Here it is a constant parallel to the time axis. Okay, next point. Next one. For motion with uniform acceleration. For motion with uniform acceleration. For motion with uniform acceleration. Uniform acceleration, displacement time graph. Displacement time graph. Displacement time graph is a parabola. Displacement time graph is a parabola. Is a parabola. Okay, so that means இங்க வந்து நம்ம discuss பண்ணும்போது displacement versus time period lo the velocity was increasing. When the velocity was increasing, acceleration is also increasing. Acceleration is also increasing. Okay, so next point in that, the velocity time graph is a straight line. The velocity time graph is a straight line inclined to the time axis. Inclined to the time axis. When it is inclined to the time axis, so then the motion is uniform acceleration. Then there is an acceleration. Then there is an acceleration. Okay, so these are your graphs under acceleration time. Okay, so any doubts in this? Any doubts? Doubt in the please ask me now itself, or else we will do some problems on this. Graph based we will do some problems. Doubt irukama?
No, sir.
Right, ma. So just take a question. Take a question. First question. The velocity time graph of the motion, the velocity time graph of the motion of a car, is given. The velocity time graph of the motion of a car is given. Okay, just draw the graph. Time. Okay, so it is your velocity. Okay, so here the graph will be like this. Graph will be like this. So it is a straight line. So it will be 3 into 10 power 8 centimeter per second. 3 into 10 power 8 centimeter per second. So it is A point, B point, C point, D point, E point, and F point. So the time periods are, so it is 2, 4, 6, and 8. 2, 4, 6, and 8. Draw this graph. Find the distance traveled by the car. So graph draw panikonga. Let's see the question. Find the distance traveled by the car in the first 6 seconds. We are going to find the distance traveled by the car in the first 6 seconds. First 6 seconds. What is the deceleration of the car during the last 2 seconds? So in the first 6 seconds, we are going to find the distance. We are going to find the distance, and the last 2 seconds. On the last 2 seconds, we are going to find the deceleration. It was a decreasing acceleration, deceleration, or retardation. Deceleration we are going to find. This is your graph. Okay, so one by one we'll see. So in this graph, if you see that, first we are going to find the displacement. To find the displacement, so the distance on the A point to E point, the time period was here 6 seconds. In the 6 seconds, we are going to find the displacement. To find the displacement, இது வந்து நான் area wise segregate பண்றேன். Area wise segregate பண்றேன் because the velocity is velocity versus time graph இது. Velocity versus time graph. Now, area versus segregate பண்றேன்னா, first case is your rectangle, triangle, okay, and the second case was your rectangle. Okay, first case is your triangle and second case was your rectangle. When you add these two, the areas, this is your total displacement. Okay, one by one we'll see. So first of all, for this rectangle, triangle, for this triangle, what is the area of a triangle? It is nothing but half length into breadth. Half length into breadth. But here the time period and the velocity on the centimeter per second. Velocity on the centimeter per second. So we are going to discuss with respect to centimeter per second only. Now, so for this one, for this triangle, first case, okay, the area is nothing but half into length into breadth. So here the length I'll consider it as 2 into breadth is 3 into 10 power 8 centimeter per second. This is your first case. And the second case, rectangle. The rectangle, again, the portion, so the length is nothing but your difference here. So 6 minus 2. It is 6 minus 2 into the breadth is around your height. So which is around again 3 into 10 power 8 centimeter per second. Okay, when you are adding these two, you'll get the displacement. So when you are adding these two, we'll get like, so it is 2 will get cancelled. So it is 3 into 10 power 8 plus 6 minus 2 is 4. 4 into 3 is 12. 12 into 10 power 8. When you're adding these two, so the relation is 15 into 10 power 8 centimeter per second. The answer is 15 into 10 power 8 centimeter per second. When you are converting it to meters, now meters lo convert panna, it is around centimeters into 10 power minus 2. So it is 15 into 10 power 6 meter per second. This is your displacement. Okay, it is meters. 10 power 6 meters. This is your displacement. Now we got the displacement. And the last 2 seconds, we are going to find the acceleration. Last 2 seconds, we are going to find the acceleration. To find the acceleration, and like a velocity theorem, initial velocity theorem, acceleration theory, we need to find the acceleration time period theory. So from the relation, V is equal to U plus AT. From the relation, V is equal to U plus AT, we are going to find the acceleration here. But acceleration, it was decreasing acceleration. We call it as retardation. Okay, just take this relation, then we will see the acceleration. Note பண்ணிக்கோங்க first. Okay, over. Okay. Now we'll see this acceleration. To find the acceleration, so velocity is equal to v is equal to a plus c. So the final velocity, because it was reaching 0, final velocity v is equal to 0. So 0 is equal to initial velocity same 3 into 10 power 8. So it is 3 into 10 power 8 plus acceleration and period. Time period the difference between 6 to 8. The difference is nothing but 2. Okay, because it is a decreasing acceleration, we'll get minus. So from this relation, a is equal to minus 3 into 10 power 8 by 2. A is equal to minus 3 into 10 power 8 by 2. So if you see that, it is nothing but minus 1.5 into 10 power 8 centimeter per second square. Or we can write it in meters, minus 1.5 into 10 power 6 meter per second square is your acceleration. This is your acceleration. Okay, over.
Sir.
Okay, ma'am. So next we'll see one more. Next question note பண்ணிக்கோங்க. Next question. The velocity time graph. The velocity time graph. The velocity time graph of an object. The velocity time graph of an object moving along a straight line. Moving along a straight line is shown in figure. Moving along a straight line is shown in figure. Is shown in figure. A point, B point, 2, 5, and here it is 10. So the x-axis is time period and it is 20. So it is your velocity meter per second. Velocity. Okay, this is your graph. Okay, calculate the distance covered by the object. Calculate the distance covered by the object between first one between t is equal to 0 to t is equal to 5 seconds. We're going to find the displacement between t is equal to 0 to t is equal to 5 seconds. And second one, t is equal to 0 to t is equal to 10 seconds. T is equal to 0 to t is equal to 10 seconds. Try to find the distance covered. So first on the 0 to 5 seconds find out pananga, next one 0 to 10 seconds. Okay, same thing. These are the 3 different areas I split panikreen. Area of a triangle, area of a rectangle, and area of a triangle. Okay, so when you're doing it, you're going to add all the displacement, you're going to find it. So then you try pananga. We'll see that. First try between t is equal to 0 to t is equal to 5 seconds. Then t is equal to 0 to t is equal to 10 seconds. Try it.
First one is 40, sir.
First one is 40. No, my first one is 80. First one is 80.
To add, sir, the triangle and rectangle.
Yes, ma. You have to add it. Add மட்டும் தான் பண்ணணும். ஏன்னா ஏரியா கவர்ட்ல டோட்டல் ஏரியாஸ் கவர்ட் தான் நம்ம டிஸ்பிளேஸ்மென்ட் டிஸ்டன்ஸ் சொல்லிட்டு இருக்கோம். First one answer is 80 meters. Sir, இது நான் பண்றேன்.
Second is 180, sir.
Second one is 130. Second one is 130. Okay, first in the triangle area பார்க்கலாம். So triangle area வந்து half into, so the base is 2 into the height is 20. So it is 20. Okay, so now 2 will get cancelled. So this is only 20 meters. The displacement is only 20 meters. Rectangle பார்க்கலாம். So rectangle வந்து the difference, it was within the portion between 5 to 2 seconds. 5 to 2. So it is nothing but 3. So 3 into 20. 3 into 20. So 3 times 20, it is 60 plus 20. It is 80 meters is your answer. This is your answer, 80 meters. Okay. Now, so upon the balance portion. So now t is equal to 0 to t is equal to 10 seconds. 0 to 10 seconds. So only in the portion மட்டும் தான் add பண்ணேன். So in the portion I want to find out the difference. If you see that difference, 10 minus 5. 10 minus 5 is 5. So 5 into 20 and half by 2. So it is 10 times ago, it is 50. So 80 plus 50 is 130 meters. This is your answer. Okay, just on the areas I add pandra, you'll get this answer. Got the answer, sir. Okay, fine. Others, if doubt in the please ask me. So whatever concept is relative velocity, then the chapter is over. So நாளைக்கு நம்ம vectors start பண்ணலாம். If the doubt irka, please ask me. If the doubt in the relative velocity whatever concept irka, we'll complete it now. No sir, okay fine. Others இருக்கீங்களாப்பா கொஞ்சம் ரெஸ்பாண்ட் ஆவது பண்ணுங்கப்பா. Okay, fine. Right. So next one is your relative velocity. Next concept is your relative velocity. இது சின்னதுதான். So இதுல வந்து problems நிறைய இருக்கு. Problems important தான். Okay, இதே relative velocity பேஸ் பண்ணி vectorsல வந்து ஒரு கான்செப்ட் இருக்கு. Okay, அந்த கான்செப்ட் அந்த ரிலேஷன்ஸ் ரொம்ப இம்பார்ட்டன்ட். Okay, relative velocity. Make a heading relative velocity. Relative velocity. Okay, relative velocity. Okay, a simple example, simple relations based பண்ணி நம்ம வந்து முடிச்சிடலாம் இது. Then நாளைக்கு வந்து 1 or 2 sums இதுல வந்து பண்ணலாம். So என்ன டைம் ஆயிடுச்சு, மேம் ஆல்ரெடி வந்துட்டாங்க. So assume there are two objects are there. There are two objects are there. Already சில பேருக்கு தெரிஞ்சிருக்காது relative velocity. So there are two objects are there. So நான் வந்து எப்படி கம்பேர் பண்றேன்னா, if the two vehicles or two objects are moving with the same velocity, same velocity in the sense either a velocity VA, either a velocity VB. Both are traveling with the same velocity, VA equal to VB. Okay, now இப்போ நான் என்ன பண்றேன்னா இது தனித்தனியா இருக்கும்போது VA VB ன்னு சொல்றேன். When you are relative with respect to one point of the point, இதுதான் நம்ம vectors discuss பண்றோம். One with respect to two. So assuming in the vehicle A ல வந்து நான் இருக்கேன், so B vehicle there is one more guy. So when we are comparing the speeds with one with respect to each other, so நான் என்னோட speed வந்து I'm comparing with A point to the B point. So I'm comparing my speed to the other vehicle. So VA with respect to B. அதே மாதிரி B object வந்து when it is comparing his speed with respect to the other. So it is VB with respect to A. Okay, VB with respect to A. So if you see that both velocities are same. For example, both are traveling in the same direction, both velocities are same. The velocity VA minus VB equal to 0. If both are same, VA minus VB is equal to 0. Suppose if both are different, so when I'm comparing with VA with respect to B, the velocities are different. So the relation is VA was compared with respect to B. The difference will be there. So VA minus VB. And VA and VB minus VE. So this relation will be there when both are traveling in the same direction. Both are traveling in the same direction. Same direction VAB is equal to VA minus VB, VBA is equal to VB minus VA. This is your relative velocity, both traveling in the same direction. Suppose if one vehicle was traveling in opposite direction, opposite direction so the relation will be like this. So it is A, it is moving in opposite direction, so it is VA. Okay, so now VAB is equal to both are in opposite direction, so it is VA minus of minus VB. So then it is VA plus VB. Both are in opposite direction, the relation is VA plus VB. So for the same thing, VBA is equal to VA minus of minus VA. So it is VA plus VB. When both are opposite direction, the relation will be same. So these are the two cases. In the two cases based on the problems we got as relative velocity. Okay, the relative velocity based on we'll do some more problems tomorrow. This is very important. Simple relation, very important. Vector there are so many relations are there dependent on this one. Okay, so tomorrow we'll continue from this one. We'll do some problems. Okay, ma'am vanditanga. Okay, any doubts? Please ask me now, or else tomorrow we'll see.
No, sir.
Right, ma'am. Okay, so tomorrow we'll see. Okay, thanks.